Hello guys, we're gonna continue to the trigonometry particle solved equations. So please, when you continue, please make sure you subscribe, like, comment and share, and also refer to a friend so that he or she can get some sample questions. Okay, we're gonna continue. We know from our previous video we found a lot of some trigonometry identities, how to come up with them. So I can refer you to look from the past video, you get some full content how we came up with the following questions, some identities which I'm gonna do some a preview, a little preview, so that we can go together. Yeah, from the previous video we know that sec theta is equals to 1 over cos theta. Yeah. And then we found that cosec theta is equals to 1 over sin theta. And then tan theta is equals to sin theta over cos theta. And then we continue to cot. Yeah, cot theta is equals to 1 over tan theta. Since we have, and now because we have 1 over tan theta and we know what is the tan theta, so we can divide the tan theta. The tan theta, so we divide 1 over tan theta, and then tan theta is sin theta over cos theta, so we divide, which will be automatically 1 over sin theta. Yeah, so you see, because we divide by cos theta, now we can multiply by cos theta. So we multiply it by cos theta, the 1 over sin theta, we multiply by cos theta. Yeah, so it will be cos theta over sin theta. So that will come up, we shall find out that is a cot theta. So I think I've simplified it to the best I can. Yeah, let me number them: 2, 3, and then number 4 I think the cot theta. Yeah, so that's okay. Before I continue, remember we have a general equation. Visit my previous page, my previous video. Yeah, I've simplified a lot of general equations which will help you a lot. So from the general equation, we know that since squared theta plus cos squared theta is equals to 1. Now I'm gonna do some sample questions. Keep following up. Now we're gonna prove the following identities: that tan theta plus sec theta over sec theta into brackets 1 plus tan theta over sec theta, you close the bracket, is equals to 1. Okay, first of all we start with the numerator. Okay, on the numerator we have the tan theta and sec theta, so we start with tan theta. Yeah, tan theta is equals to sin theta all over cos theta, and sec theta is equals to 1 over cos theta. Now we start sin theta over cos theta plus 1 over cos theta. The LCM will be cos theta, so we use the cos theta as our LCM. So cos theta, yeah, the cos theta goes 1 to sin theta. No, it goes 1, yes, sin theta, yeah, plus 1. So that's our numerator. We go to the denominator. On the denominator part, we start with the brackets. The brackets part, which we start with the brackets. Yes. On the bracket side, we have 1 plus tan theta over sec theta. Yeah, on the bracket side. Yes. So tan theta is equals to sin theta over cos theta, and sec theta is equals to 1 over cos theta. So we start sin theta over cos theta divided by 1 over cos theta, which will be sin theta over cos theta times cos theta over 1. We close multiply. Now we cancel the cos theta, and the cos theta will remain with the sin theta, which will be 1 plus sin theta on the numerator side. And then we remember we have sec theta outside, which is the sec theta, which is 1 over cos theta. So it will be 1 plus sin theta over cos theta. Our LCM will be cos theta. Yeah, cos theta. So when you do the inverse, now we divide the numerator and the denominator, and then when you divide, automatically it will change. You go to multiplications. Now we cancel the cos theta and the cos theta, and the sin theta plus 1, which will give us 1, which is automatically on the part 2. So we're gonna go through, find 1 plus cot theta over 1 plus tan theta is equals to cot theta, and then we know cot theta is equals to 1 over tan theta, which can also be cos theta over sin theta. Yeah. So 1 plus cos theta over sin theta is equals to sin theta. After we have done the LCM, it will be, after we have done, since our LCM is sin theta, it will be sin theta plus cos theta. Yeah, because it will go there once. Yeah, it will be cos theta. Okay, that's the part. And the numerator part, we go to the denominator. To the denominator, we have 1 plus tan theta. Yeah, 1 plus tan theta. Tan theta. So from the, we know that tan theta is equals to sin theta over cos theta. So we go 1 plus sin theta over cos theta, which will be, so our LCM is cos theta. So we go, because since you know the LCM is cos theta, so cos theta goes there once, and then it will be 1. Yeah, so it goes there, cos theta. Yeah, and then there it goes, cos theta, it will be the sin theta. Okay, now I think we divide the numerator, the numerator and the denominator. So our numerator was sin theta, numerator, sin theta plus cos theta over sin theta divided by cos theta plus sin theta over cos theta. So we're gonna multiply. We take the numerator to the denominator, and the denominator to the numerator. So the first part will remain the same, but the second part, since we're gonna multiply, we interchange. So it will be there cos theta over cos theta plus sin theta. So we see sin theta plus cos theta, and there we have sin theta plus cos theta, so they can cancel each other, and the one remaining will be cos theta over sin theta and sin theta. Cos theta over sin theta is equals to cot theta. we can refer there upward that cot theta is equals to you see cot theta is equals to 1 over tan theta, which is also the same as cos theta over sin theta. Now we've got our answer. That's correct. Yeah, that's cos theta over sin theta. And then we are good to go. Now you can go to 1 minus sin theta plus 1 over 1 is equals to 1 over sec theta plus tan theta squared. So we start from the right side. The numerator and the numerator is 1. So we don't have to do many calculations since it is all 1. Yeah, we start from the right side because it's the one who can expand and find the functions. So we go to the denominator. On the denominator part, we have sec theta. No, it's so since it is squared, it will be sec squared theta plus tan squared theta. So, and we know sec squared theta is equals to 1 over cos squared theta, and tan squared theta is equals to sin squared theta over cos squared theta. So we'll go 1 over cos squared theta plus sin squared theta over cos squared theta. Now we can evaluate. Our LCM will be automatically cos squared theta. So we continue. So we use cos squared theta as our denominator. So cos squared theta goes there once, so it will be 1 plus, it will go there once, plus sin squared theta. Yeah, so I think we're through. But we know that sin squared theta plus cos squared theta is equals to 1. Yeah, so it will be 1 plus sin squared theta over, no, so when you see you have the cos squared theta, yes, and so the cos squared theta, it will be 1 minus sin squared theta, because the general equation is sin squared theta plus 1 over plus cos squared theta is equals to 1 minus sin squared theta. So that's a cos squared theta. So all of them have squared, and you know a multiple a minus, when you find a minus b squared, that the identity can be the probability of the identities will be a minus b squared. It will be a minus b into brackets and a times a plus b squared. So we're gonna use the same equation, that 1 plus sin theta over 1 minus sin theta is equals to 1 plus sin theta over 1 plus sin theta. Yeah, because when you expand these two equations, it will give you the same 1 plus sin squared theta over 1 minus sin theta. You can prove it. So when those two will cancel, I think we shall resume with our answer, that it is that one from the equation we had been given there. We know that